Good morning. Hello, boys and girls. Welcome to our science class. So we are still on the topic, how is heat transmitted? All right, so today's objectives. You should be able to define the terms conduction, convection, and radiation. You will also investigate how heat can be transferred through the particles in solid, liquid, or gas. You will also explain the direction in which heat energy is transferred or transmitted. All right, so I have attached a video in your Google Classroom. So in your own time, you are going to watch this video. All right, so three methods of heat energy transfer are conduction, convection, and radiation. Now, conduction is the method of heat transfer in solids. Conduction is the method of heat transfer in solids. Convection is the method of heat transfer in liquid and gas. And radiation is the method of heat transfer through an empty space or vacuum. All right, so here is a picture showing the particles in gas, liquid, and solid. So as you can see in picture 1, that's this picture, gas. These are the particles in gas. Now, the particles in gases have a lot of energy. They are further apart from each other and moves very fast. So as you can see the particles in my container here, they are further apart from each other and they move very fast, right? So gases, they have a lot of energy. That is the particles. The particles in gases have a lot of energy. All right, now liquid. The particles in liquids, as you can see here, these are the particles. They have more energy. They are separated from each other and have little movement. So as you can see, the particles, they are separated from each other and they have little movement, right? But yet they have more energy. All right, solid. The particles in solids have very little energy. They are close together as seen and vibrate against each other, right? So they are close together and they vibrate against each other. All right, so investigate how heat can be transferred through the particles in a solid, liquid, or gas by doing the following activities. So you might need to get a partner at home. I know you're at home, so you can ask your brother or your sister or whomever is at home and is available. Now what you're going to do, you're going to stand shoulder to shoulder with your family member or family members. And you're going to vibrate to show how the particles in solids are arranged and behave when heated. So when you're standing shoulder to shoulder with your family member, you start vibrating against each other. That is the same way the particles in solids, they behave when they're heated. They go up and down, up and down. All right. And they're close to each other. All right, next, you're going to demonstrate heat transfer in liquid. So you can stand a foot apart from your family member and dance, jig, or stretch and touch each other. So that is how heat transfer behave in liquid? So they jig and they stretch to touch each other. All right. So in gas, the particles are farthest apart. So you will jump and bounce to touch each other so that the heat is transferred. I hope you have fun doing those. All right. So with your partner at home, you're going to discuss the key points about how the particles in solid, liquid, and gas behave when heated. You will state the reason heat is transferred fastest in solids and slowest in gas. All right. So remember, you're going to discuss the reason heat is transferred fastest in solids and slowest in gas. So please note, the particles in solids are tightly packed. So the particles which are heated quickly transfers this heat to others. The gas particles, they are far apart and have to travel farther to touch one another in order to transfer the heat. All right, so look at the cartoon image on page 137 in the text, First Steps in Science, Year 5, for those of you who have the books at home. If not, you can just look at my diagram here. Now, as you can see, here I have a mother and two children sitting. Well, the mother is standing, the children are sitting at the table, right? As you can see, a bowl of soup is in front of the boy, and the girl has a glass with some juice in her hand. All right, here is what mother said. John, drink your soup before it gets cold. Drink your lemonade before it gets warm, Sharon. Now, why will John's soup become cold and Sharon's lemonade get warm if they are left on the table? Think about that. Would both liquids reach the same temperature if they were left on the table for a long time? Think about that as well. Now, how does that happen? Can heat travel from one place to another? So these are some questions that I want you to think about. All right, so you're going to answer the following questions. In which method of heat energy transfer will heat energy travel from the soup to become cold? Then, in the case of the cold lemonade, what direction will the heat travel? Think about it. Remember, it is said that heat energy is always transferred from a hotter to a colder substance. Heat is transferred, not cold, so heat will travel from warmer air to colder lemonade, making the lemonade warm. When two substances are at the same temperature, no heat is transferred from one to the other. So those are some important information to note. Now, something to do. You are going to record notes about the lesson under the headings, methods of heat transfer. Remember, the methods are conduction, convection, and radiation. Now, how heat affects the particles in solid, liquid, and gas. You're going to also state the direction in which heat is transmitted. Remember, from hotter to colder. All right, so state the method of heat transfer that takes place in the following situations. A, boiling water. B, the sun heats a zinc roof. C, hot air leaving a factory through the chimney. D, ironing clothes. E, warming food in the microwave. All right, I'm looking forward to seeing some accurate, neat, clean, and tidy work. All right.